So, I'd like you to pause the video and look at this problem. And based on what we just did, see if you can at least do part A. And then you can continue with the video. I'm going to continue with the solution now. Alright, so let's look at A. We want to know g of 0 and g prime of 0. And we know that g of x is equal to the integral of -3 to x of f of t d of t, and we have the graph of f. So just like in the previous one, we're going to put g of 0 equal -3 to 0 f of t d of t, and if we come over here and look at -3 to 0, it's this little section in here. And so that's a trapezoid. So we can do 1/2 times the height times the two bases. So we've got, so let me get our little, so you can see where we are. So we're right there. So we let our height be the 1, 2, 3. 1/2 is part of the formula. One base is what? 1, and the other base is 2. So if you work that out, you get 4.5. Now, g prime of 0, we're going to take the derivative of g of x, because g of x is equal to this integral. And by second fundamental theorem of calculus, that'll be f of x. So we'll just look at f of 0 on the graph, and f of 0 is 1. Now, part B says find all the values of x in the interval -5 to 4 at which g attains a relative maximum. Justify your answer. So remember, this is the first derivative graph. So to have a relative maximum, it would have to change from positive to negative, because positive first derivative would mean your original is increasing, and then negative would mean it's decreasing, and that would give you a max. So if you look at the graph where it changes from positive to negative is at x equal 3, because it's positive and then it changes negative. And as I explained, you could just write it down. G will obtain a relative maximum where the first derivative, g prime of x, which equals f of x, turns from positive to negative. So part C says find the absolute minimum value of g on the closed interval -5 to 4. Justify your answer. Now remember the word absolute, you're going to include your endpoints. So we need to check endpoints and critical points. So we got an endpoint of g of -5. We've got a critical point at 4, -4, 1, and, well, that's our other endpoint. And then we've got a critical point at -4, 1, and 3. Well, we can exclude g of 3 because we just said that's going to be a relative max, and they're talking about absolute min. And if you look at g of 1, the sign doesn't change, so that's not going to be a max or a min. So these are the three areas that we're looking: -5, 4, and -4. So if we come here and we put g of -5, we're going from -3 to -5. Our lower bound is not in the right order, so we're going to need to change that. So we put a negative out front. And when you come over here and you look up at the graph, you can just do your geometric shapes. So you're going from -5 to -3. So you got what? The two triangles. Remember, this triangle is underneath the x-axis, so it's going to have another negative. So you got the negative from the interval, and then you got this one, 1/2, 2 times 1, and 1/2, 2 times 1. And so you get negative 1 plus 1, hold on. So I had to catch my error there, because this negative is out after you add these two. So they're going to negate each other, and you're going to get 0. So now to do g of 4, we're going to do negative 3 to 4. So if you look at the graph, and I'm going to break it up from negative 3 to 0, because that'll be my trapezoid. And then from 0 to 2, now look at this 0 to 2, because you got to be careful here. You've got this semicircle, but the area you want is right in this little thing. See, underneath there? So what you got to do is make the rectangle and then subtract out the semicircle. So you got the rectangle minus the semicircle. And then this little shape's a triangle, and this little shape's a triangle. So that's taking you from negative 3 to 4. So if you look up at the graph and do the trapezoid, that's going to be 4.5. If you do this little rectangle, it's going to be 2 times 1, and then you take out the semicircle, and then these two triangles are going to negate each other. So you get 4.5 plus 2 minus pi over 2, which is 6.5 minus pi over 2, or approximately around 5. And then our last one, g of negative 4, we're going to do negative 3, negative 4. We're going to reverse it because we need to get our lower and upper bounds right order. And then that'll be a little triangle. And so you're going to get negative 1. And so this one would be the absolute minimum, g of negative 4, because negative 1 is less than 5 and less than 0. So this next example is a really good one, because happens a lot on the AP exam, where you have something called a starting point. So if you look, they give us the graph of g prime, and it says the function g is defined and differentiable on the closed interval negative 7 to 5, and satisfies g of 0 equal 5. So anytime, now notice this is the graph, the first derivative, anytime they give you a value for the original function, that's going to be kind of like your starting point when you do your integrals. So I've circled that and put starting point. And it says the graph of y equal g prime of x. The derivative of g contains a semicircle, 3 line segments shown in the figure above. So it says find g of 3 and g of negative 2. Okay, so let's think what g of x is. G of x is g of 0, because that's our starting point, plus 0 to x of g prime of x, because it's your accumulation of the shape. So using that, we can come down here and do g of 3. So we're going to do g of 0 plus 0 to 3 of g prime x dx. Well, they told you that was 5, and I'm going to break this up 0 to 2 and 2 to 3, because if you go 0 to 2, you got a quarter circle, and then 2 to 3, you've got your triangle. And always remember, in these, if you don't have a function rule, then the only other way you can find it is by the geometric shapes. So we've got 5 plus 1/4 pi, the radius 2 squared, plus the little triangle, 1/2 times 1, because we just want this little part, times 3. So you get 13 halves plus pi. So that's the value of g of 3. Now, for g of negative 2, as we did in the previous examples, we do g of 0. Now, you always have to include your starting point, because that's the definition of the function, because y is just g prime. So g of 0 plus, then we'll go from 0 to negative 2, g prime of x. Okay, so g of 0, we're going to switch the order, minus g prime of x, and so we get 5 minus 1/4 pi 2 squared, and we get 5 minus pi. Now part B says, find the x-coordinate of each point of inflection of the graph of y equal g of x on the interval -7 less than x less than 5. Explain your reasoning. Okay, so point of inflection is where concavity changes, and remember concavity is the second derivative. So this, where the second derivative is negative, it's concave down. Where the second derivative is positive, it's concave up. So you want to look where the first derivative is increasing, second derivative positive, first derivative decreasing, second derivative be negative. So if I look at the graph where it changes from increasing to decreasing, because this is the first derivative graph, I get x equals 0, x equals 2, and x equals 3. Now part C is a little bit tricky, but remember on free response, you're not going to get every section. You hope you get A, B on all of them, and most of them you'll get C's and D's, but occasionally. But let's look at it. It says the function h is defined by h of x equal g of x minus 1/2 x squared. Find the x-coordinate of each critical point of h where -7 is less than x less than 5, and classify each critical point as a relative max, relative min, and explain your reasoning. So let's get our critical points first. So we know h of x is g of x minus 1/2 x squared. So remember how you get critical points. You get the first derivative and set it equal to 0. So if I take the derivative of h, that would be the derivative of g, and then I would take the derivative of -1/2 x squared, so I get minus x. So how do I set this equal to 0? Well, I do this, carry the x over, so that means you're looking for where the value of x, so where your input equals your output. So if you go up and look at the graph, you definitely got what? 3 equals 3. So x equals 3 is one of your critical points. So that, I think you might could have figured out. The part that I think is a little tricky, so it says y equals g prime of x. So if you look at this part, you've got the equation of a circle. I'm just going to show you this. Whether you would remember this, I don't know. But you've got the equation of a circle. Remember the radius is 2, the center is 0. So the equation of a circle is x squared plus y squared equal r squared. So that'd be 4. So if I solve for y, it'd be plus or minus the square root of 4 minus x squared. And so where you've got g prime of x equal x, you can substitute you want where y equal x. Well, if I let x be plus or minus square root of 2, that happens. Y equals x, because look, if I put square root of 2 in there, squared, I get 2, 4 minus 2, I'm back to what? Square root of 2. So I'd have the positive and negative. So the three critical points I have is x equal 3, x equals square root of 2, and x equal negative square root of 2.